Hello friends, welcome once again to this Lambda deep dive session. So in previous session we have seen what is cold start and what is the drawback of Lambda. If you have not watched that video, I would highly recommend to first watch that video. You will get the link in the I button and then continue here, because this is very important to understand the reserved concurrency. If you understand what is cold start and what is Lambda, then only you will able to understand better what is reserved concurrency in the Lambda. Right, so let's get started. So in the previous lecture we have seen that once we invoke the Lambda, right, so first it will initialize the container and then execute and then get terminated, right? So this is what called cold start. And if Lambda is already warm and if you send the another request, then it will not do the initialization again, and it will execute the code directly. So we have seen the practical this as well. So now let's come and understand the reserved concurrency. And why this reserved concurrency is important, right? So each and every account, right? And in one account, so suppose we have here AWS, right? So we have AWS account. Then in the AWS account, you will be having some Lambda invocation limits, right? That is generally 1000, right? So this, the maximum concurrent request you can send to AWS on Lambda is 1000, right? So if you send 1001 request, then it will throttle, right? That request will be lost. So why this is happening, right? So suppose you are using Lambda in different lambdas. So why it is happening? Suppose you are using Lambda for different microservices or different services, right? So suppose one is here like for the payment, right? So suppose this Lambda consumed, so this is some other Lambda for some data processing, and suppose this Lambda is consuming lots of requests, right? So you get lots of invocation for this data processing Lambda. So what will happen at one time? Suppose this Lambda has consumed all 1000 requests, right? So all 1000 requests has consumed by this data processing Lambda. So if any user trying to do the payment, right? So the payment will not be completed, and that's a crucial part of any business, right? To get the payment. So to save these kinds of situation, what we will do, we will reserve some Lambda. Suppose we want to reserve here some 50 Lambda, right? So what are the remaining Lambda will be left? So in one account we will be having 1000 Lambda less than 50. So 50 we have reserved for the payment. So remaining 950 Lambda will be remaining to be consumed by other Lambda in the application or in that account, right? So in that way, if any critical feature or critical task needs to be happened at certain time in the application, that will not be get impacted. So let's understand this more with a simpler example. Suppose you have set Lambda concurrency limit to 2, right? So like we have set here 50. So you have reserved that so you have reserved 2 Lambda invocation for that particular. So basically you have reserved 2 invocation or 2 concurrent parallel execution for that particular Lambda, right? So if you have set it to 2, so suppose the first request comes in, right? So it will execute as usual, we have explained in earlier lecture. The second request comes parallelly, it will execute. And suppose these requests are completed, then the third request comes, it will execute. Fourth request it will execute. So at a time you will see only 2 parallel execution will be possible, right? Only 2 parallel execution. If you try to execute more, right? So suppose you have now now you have more requests over here, right? So the first request comes in, it is executing, that will go smooth. The second request comes in parallelly, it will go as smooth. But if these 2 requests are still in progress, are in the execution phase, the third request comes in, this will fail. The fourth request comes in, it will fail. All these requests will fail because we have reserved this Lambda, right? And this will only execute 2 concurrent executions or 2 parallel executions, right? So all this Lambda will be failed. So now let's see this in practical. So let me create a Lambda. I am in North Virginia region. Let me create a function from scratch. Coding, hello world coding Jist. You can take any name. All the things are default, just creating a function. Let me go to the configuration, and once the Lambda is created, you need to go to the configuration and you need to go to concurrency and recursion detection. So let me edit. So I want it to set to 2. Okay, now you are getting this error that the unreserved account concurrency cannot go below 10. So what happens, right? Why you are getting this error, since you have not set any concurrency for any of the Lambda. So if you go in functions, you will see only I have 1 Lambda and we are trying to set the concurrency, reserved concurrency 2, but we are not able to do. So to understand this better, let me go to the dashboard. So you can see that we have only unreserved account concurrency to 10. Full account concurrency is already full. The account concurrency is already full. So why? If we have not set. So why this 10 is already set, right? Let's understand that. So once you create Lambda, there are so many backend process happens, like you log the request, right? You invoke, you monitor, and you trace. For all these things, we need some resources, right? To reserve those resources, the AWS already set it to 10, right? Now I am in this North Virginia region and this is 10. So this is a soft limit, you can increase it. So how the process of increasing this limit, I have already created that video. You will get that in the I button link. You can watch that. So let me go in another region where I have increased that limit. So let me go to AP South 2. You can see here, right? So we have 1000. So let me create a function over here. Same thing, nothing extraordinary. So the function is created successfully, and let me go to the configuration of this function. Same concurrency. Now edit and let me set it to 2. Right. So now you can see that it is saved properly. And one more thing we wanted to we need to edit here is go to general configuration. We'll see the timeout. I want to increase it to 4 minutes. I'll let you know why I'm doing this. Since it is 3 seconds, right? So I want to execute one code over here to simulate this experiment. Let me go to the code. So what I'm trying to do, so I'm just removing this normal code and writing my code. So what we are trying to do in this code, right? So we basically want to delay this function for approximately 5 seconds, right? So if the timeout for this function is 3 seconds, then definitely this code is not going to work. Before the code completes, it will get shut down automatically, right? So what we are doing, we are taking a default delay of 5 seconds, and we are passing this as well, right? So I have already explained you what is event and what is context in my previous video, that is event driven architecture. You will get the link in the I button. If you wish, you can watch that as well. It's very important to understand what is event and what is context. Right? So we are receiving the delay. If the delay is not there, it will automatically take 5 seconds. Then we are making this function to the sleep, right? Set timeout for 5 seconds, and then we are just returning the response, right? So let me deploy this code, and to invoke this function, we need to attach the API gateway as well. Why, right? So let me explain that thing. So we have one lambda. We have created this lambda. Now we need API gateway, right? We need API gateway so that once we want to invoke, right, we can invoke the API gateway and it will trigger the lambda, right? I have explained all this thing, how this works. So we'll create one route here, right? We'll create post route, and we'll send some data, right, which we are receiving in this code, right? So we can see that we have event.body, right? In the body we will send it. So let me create API gateway, create API, build. All right, so let me say we will integrate. What we'll integrate? We'll integrate lambda, maybe south 2. We have only one lambda, right? Hello world. And next we will add route. We'll add post route. Let me give the path. Hello. We want to integrate with this. Okay. We can add get route as well, same lambda. Next, I want to deploy to dev stage. Right now we have done the integration. We have created the routes and then create. And one thing to notice over here, right? So as of now, if you see, we do not have trigger. Right, so once this is created successfully, we'll refresh this page and you will see the trigger has been added, right? API gateway is the trigger for him. Now let me go to stages. Dev stage we have deployed. Let me get this. Go to API gateway. Let me add a new request, right? So let me add here. We have given the path as well, right? Hello. Now if we send the first time, it should take some time because of cold start, right? You will watch my previous video to understand why it is happening. Now we need to execute post method as well. For the post method, we need to send some body, and we'll be sending raw and JSON, right? So let me give only 5 millisecond delay. Now you can see that post is working fine. Right? If we are giving 5 millisecond delay, it is taking 5. If we are getting 1000, it will take 1 second and then response. Right? You will see here 1 second. Then it is sending the response. So I'm setting it to 5000. Right, now it is taking 5 seconds. So as of now we are sending one request at a time, but to simulate our theory, right, we need to send 5 requests at once. So it should pass 2 requests and should fail 3 requests, right? So now Postman is sending all the things serially one by one. If you send one by one, it is not going to help. But we need to send 5 requests at once, right? To do that, I have opened Fiddler. So what does Fiddler do, right? So it just log all the requests which is going out from your laptop or coming in, right? So let me send one request, this request. So you can see that we have this request. Dev/hello. Okay. Hold on. Dev/hello. And if we see here, right, so it is saying Lambda executed successfully. Now I need to execute this 5 times parallelly. So let me send one request. Now you can see that we have this request dev/hello. Let's wait for 5 seconds. So now it is successfully. Now I need to send this parallelly 5 times, right? So I'm clicking Shift+R. This is 5, right? So now you can see this here. We have sent 5 requests at once, in which 2 requests is successful, but 3 requests are failed, right? This is successful. This is successful. This is service unavailable, because at that time the reserved concurrency is set to 2. Now let's do one more experiment, right? So let me change the concurrency to 3. Right, so go here, add it to 3. Now it is set to 3. Let me go here, clear all the logs. Let me send this request once again. Dev/hello. Shift+R, 5 requests. Now you can see that 3 requests have passed, have successfully gone there, right? But 2 requests, these 2 requests have failed, right? Now let me although remove the concurrency, right? So, right, now it is set to 1000. Now let me test it. I'll send 5 requests once again. Right, let it successful. Okay, now it is successful. Shift+R, 5 requests, right? Now you can see that all the 5 requests have passed successfully, right? There is no issue in this. So this is what the reserved concurrency is. Hope you have enjoyed this video and understood what is reserved concurrency and when to set that. So thanks for watching this video, and I would request to subscribe for upcoming Lambda deep dive series and share with your friends, and don't forget to hit like. Thank you. Have a great day. Bye-bye.